Okie dokie. All right, so in general, you guys know we have a reaction in terms of our lab that we're getting ready to do between a metal, unknown metal, and what? Okay, so we have one version that's going to be between metal and hydrochloric acid, and that's what this pre-lab is referring to. What's the other acid in our lab? Look in the lab. Don't be guessing. Look in the lab. Procedure. Sulfuric acid. Okay, so we are going to run both trials. It's not optional, okay, because we have large lab groups and we can kind of tag team on those. So this pre-lab specifically references hydrochloric, but you're going to be thinking the same way about sulfuric. Just remember that. What's sulfuric's formula? H2SO4, which would modify your balanced chemical equation, and then potentially your moles, and then potentially how you just barely mathematically different. Okay, so I'm going to show you guys how to set up. It's a very easy lab. We get our results like this, but we should have to be careful because we're dealing with 3 molar, pretty dang concentrated. I actually made it yesterday fresh, and it gets very, very exothermic when you make sulfuric acid from stock, and it melted about this much ice in about 10 minutes because it's so exothermic. So just have to be careful with that. So in terms of questions, I'll get some more questions on your pre-lab. These are some tips for success. So if you want to jot down a couple of ideas as I talk about them in terms of your procedure. I like that a lot of you guys, and this is just me critiquing your lab notebooks because that's what I have to do to make sure that colleges accept them. You write down like my tips on the left side just to annotate a couple of ideas, and then you do all your work on the right side. Some of you guys are not leaving enough space and you're doing all your work on the on the left side, and I can't technically take that. I'm trying to. Just make sure you're writing your units, you're labeling if this is like A, B, C, or D, and you're keeping things organized. If you got to get another lab notebook, I got plenty, okay? Like, use those pages up. Okay, so what we're going to do is, in the picture on the lab, you see how this, let me come back to this. Well, where's my image? Okay. Well, there was this image here. It kind of looked like this. This is a beaker. Okay, and then you had a eudiometer tube, and the eudiometer tube has these graduations on it, and you're going to have a stopper in the eudiometer tube, but the stopper is a one-hole stopper, so it has a hole in the bottom of it, and you're going to tie a string, thread it through the hole, and your little piece of metal is going to be floating in the inverted eudiometer tube. So your piece of metal will then react with the acid, and there's water in here too, but the acid that we put inside of our eudiometer tube. So what we'll start with is a eudiometer tube that's upright, and we'll put, how do you safely add acid? So add acid to water, do what you oughter, right? So you'll have your water in here first. Don't fill it even halfway with water, just put some water in there so it dilutes it as you add your acid. You'll add your acid, and then you can fill on top with water till you get this 100% full. Okay, so then you have to be like a stealthy ninja, and you'll have to put your stopper with your string in the middle of it already and your metal hanging on the other side. Since it's full of acid and water, you'll have to put your string and metal in here and dangle it into the acid-water combo without touching the acid. Okay, and the good thing is this acid's 3 molar. It's pretty dense. It's going to sink to the bottom. It won't be close to your hand at all. But what we have to do very quickly is put our thumb on the bottom of the one-hole stopper, because the stopper will be here, and there's our one hole up here. So you'll put your thumb on the one-hole stopper and you'll flip it upside down real fast into your beaker. Your beaker will be halfway filled with water already, and so as soon as you take your thumb out, the reaction will begin. So your acid, which was on the bottom, right, because it was dense, it was up here for a moment, it starts to sink down, so HCl. And as soon as the HCl hits this unknown metal, what are we going to start to observe? Gas bubbles, right? So what gas is being produced in this reaction? Hydrogen gas, right? So as soon, and this is filled with water, right? Water acid combo. This is all the way filled with that. As the bubbles start to form, what are we going to see up here? A space, right, filled with hydrogen gas. What's going to happen to the water-acid combo? It's going to go through the hole and kind of just deposit itself in the water that's already here. so gas is doing water displacement, right? This gas that forms up here. Okay, so this gas that's up here, what do we care? Like, what measurement do we need to take on that? Say again? Say again? So some people are like really shy in their confidence. You got to be louder and prouder. Deaf lady up here. Say again? Millimeters of what? There's no mercury in here. Potentially, we need to figure out the volume of the hydrogen gas. Whew. Okay, that is something we will know from this reaction. Okay, because when you see your eudiometer tubes, you'll see how to measure that. But then we've got this big old column of water from here down to here. What do we want to do with this column of water? Because that's, in really essence, causing some pressure differences. Say again? How do I know the pressure of a column of water? Say, I can't look in the reference book. You guys have your notes? You guys have a lab in front of you. Okay, you're just to look over the lab for me. So look over that lab for me and tell me, how would I potentially handle this big column of water right here? Is that the AC? It's that loud. Any takers? Say again? All right, so what are all of our pressure units? Go for it, Gabby.
Is it the H2O times the
H2O, the height of H2O, remember this? Times the what?
density?
Density of H2O equals,
The height of
you got it, mercury. So equals the height of mercury.
times the density.
Okay, you guys remember this from notes like one random day last week? Okay, so we have to very carefully get our pressure of water to height of mercury, because that is a pressure unit. So what pressure unit am I really speaking to here? Okay, millimeters of mercury. Okay, so what does that mean I have to calculate, or measure in this experiment? William, what did you say? I have to measure the height of water. How would one measure the height of water? Say again? Graduations are in milliliters, not height. A ruler. Oh my goodness. Okay, we're going to use a ruler, and we're going to measure literally the height. Think of the instruments you guys use every day, measuring the height. Our rulers will measure in what 2 units that would be useful for us? Centimeters or millimeters, right? No inches, unless you're going to convert from inches to centimeters. Okay, so that's data collection for you. It looks a mess, but you can kind of see what you're getting here. What I have done for you here is kind of just relay that information again. So beaker half filled with water. That's going to make sure that we have enough room for water displacement to occur. Anchor your metal with a string. Put the string through the stopper. Make sure the stopper's on tight, because as soon as those gas bubbles come, it will pop that stopper out and you have to restart. Clamp the, so I didn't draw this, but the eudiometer is a big glass tube. You want to clamp it to like the metal things, rods, metal rods, so that it stays up. You don't have to babysit it the whole time. And as soon as the acid-water combo has been displaced, your whole solution in the beaker will be acidified. So how would we want to handle that? Baking soda to neutralize. Just put enough baking soda just to get the bubbles to stop. As soon as you guys dump like loads of baking soda, there's a big mess of baking soda on the bottom. We can't put that down the drain because it's solid. So put just enough baking soda to stop to neutralize the solution. Got it. Use a reference table for water vapor pressure. There's a big old book back there on the back left station. You need to get the temperature. Remember, this is gas, right? So what variables are we collecting for gas laws? Temperature, pressure, moles, volume, right? So once you get your temperature, you can look up I think it's in degrees Celsius. Look in the reference table and it will tell you the density of water and water pressure. It'll tell you the density of water and water vapor pressure. There's 2 tabs. I'll make sure you guys see them both. And then in Concord right now, it is, for total pressure, it is 30 inches of mercury. You know, we're Americans, so we like to use inches. So you guys can calculate from there, okay? So since you guys are going to be in groups of, most of you guys are going to be in groups of 4, I have one group of 3 because Jaden's not here and Emily's not here. Here's who I have for you guys right now. Look and look and look. And let's be kind and let group 4 will be at this last station here, so Crip doesn't have to travel very far. And then in terms of what I want is 2 people can start the sulfuric acid trial. 2 people can get ready for a hydrochloric acid trial. You don't have to be hands-on in both trials, but you need to be hands-on in all calculations. Okay? You guys good? Major questions? All right, let's do the last thing. We have about an hour in class. You can totally finish this lab like almost all the way. Everybody should have shoes on. Shoes. Can I take this off the board? All right, taking this off the board. Yeah, just find a lab station. I just wanted you guys to know which groups you were in. All right, guys, send somebody to the materials manager. All right, so someone else coming in a piece of metal. I almost said what it was. Metal, so you guys can mass it. That would be 2 people. Somebody else? Anybody else need metals? All right, so whenever you are massing your metals, you need to know which is 1 and which is 2. Do not mix them up because they weigh different. So the 1 will be for sulfuric acid trial, 1 will be for H2O trial. If you need to fill up your beaker, fill up with tap water. Tap water is precious. It's a precious resource. Yeah, water. How much acid are you putting in? 30 milliliters, right? Make sure that you know which acid you're putting in first. After that, you guys start. Alright, so I need to be seeing some inverted ediometers fairly soon. You guys need some help with stopper thing, let me know. Just because like I got people responsible for us and the other actions. If the stopper overflows, the water will be able to you guys can get your measurements quickly because your acid will begin to come out of the bottom and you will have to redo it. That's basically done, right? Okay, so that's now you can go to the icon. Tell me how. The water at the bottom, that's just there, like not.
Alright guys, so I have some folks who are getting ready to start. Listen, Wells 2, you need to neutralize your acidified water. There's baking soda over here. I would bring yourself maybe a beaker and scraps and bring back to your station. After you get all your measurements, you can then begin with the next section. So maybe you can look at your JC. Can I try to let this drain from the UVometer? Because the UVometer still has alcohol in it. So what you can carefully do is you can maybe carefully shake it or carefully remove the stopper without getting acid on your hand. And then remove whatever that is. And then that way, all the acid is removed from the UVometer and then you put your acid back over here so other folks can use it.
I said it was
Alright, someone is beginning the next trial.
So we're gonna need that. Very good, Christian.